method by a recurrence or mathematical induction. Exercise 1, prove that 1 square plus 2 square plus etc. plus n square equal n plus 1 to n plus 1 over 6. We try the formula for some values n equal 1, n equal 2. If n equal 1, the formula becomes 1 square equal 1 times 2 times 3 over 6. We substitute n by 1. So the formula is true for the order n equal 1. Now, assume that the formula is true for the order n, and prove that the formula is true for the order n plus 1. Prove that 1 square plus 2 square plus etc. plus n square plus n plus 1 square equal n plus 1, n plus 2 to n plus 3 over 6. We substitute n by n plus 1, n plus 1, n plus 2, and to n plus 3 over 6. We substitute 1 square plus 2 square plus etc. plus n square by n plus 1 to n plus 1 over 6 plus n plus 1 square equal 6 as common denominator, n plus 1 to n plus 1 plus 6 to n plus 1 square. We can write n plus 1 as a common factor. We obtain n plus 1 into n, 2n plus 1 plus 6 into n plus 1 over 6 equal n plus 1 into 2n square plus n plus 6n, 7n plus 6 over 6. We can decompose the trinomial 2n squared plus 7n plus 6 as product of factors. We obtain n plus 1 into 2n, n plus 2, 2n plus 3. So the formula is true for the order n plus 1. 1 square plus etc. plus n plus 1 square equal n plus 1, n plus 2, 2n plus 3 over 6. Then the formula is true for every n belongs to n. Exercise 2. Calculate the nth derivative of the function y equals sine ax plus b. We try for the order 1, y prime, derivative of order 1, equal. We have y equals sine u with u equal ax plus b, and the derivative of sine u is u prime times cosine u. Derivative of ax plus b is a times derivative of sine is cosine ax plus b. Transform cosine into sine. We add pi over 2 of the arc ax plus b. Y prime equal a times sine ax plus b plus pi over 2. For the order 2, y double prime, the derivative of y prime, derivative of ax plus b plus pi over 2 is a times a equal a square times derivative of sine cosine of the arc ax plus b plus pi over 2 equal a square. We add now pi over 2 to the arc sine ax plus b plus 2 into pi over 2. So we can now suppose that the formula for the order n minus 1, derivative of order n minus 1 equal a n minus 1, the power n minus 1 equal the order n minus 1, sine ax plus b plus n minus 1 times pi over 2. For the order y double prime, power of a is 2, and we have 2 multiplied by pi over 2. If we suppose the formula is true for the order n minus 1, we must calculate now the derivative of y n minus 1 to obtain the derivative of order n. Derivative of y n minus 1, a times a n minus 1 is a power n, cosine, we add now pi over 2. Now the derivative of sine is cosine of the same arc. Now we add pi over 2 to the arc to transform cosine into sine. We obtain the derivative of order n is a power n times sine ax plus b plus n times pi over 2. So is the derivative of sine ax plus b of order n, the nth derivative is a power n into sine ax plus b plus n times pi over 2. Exercise 3. as application to method by recurrence or by induction. Show that the nth derivative of the function y equal ln x plus 1 is fn of x equal minus 1 to the power n minus 1 times n minus 1 factorial over x plus 1 power n. For the order 1, the derivative of ln x plus 1 is 1 over x plus 1. Since the derivative of ln u is u prime over u. U is x plus 1. Derivative of x plus 1 is 1. For the order 2, y double prime, derivative of 1 over x plus 1, the derivative of k over u is minus k u prime over u squared. So y double prime equal minus k equal 1 times u prime, the derivative of x plus 1 is 1 over u squared, x plus 1 squared. To show the formula, we must also try for the order 3. Y tiers of x equal derivative of k over u is minus k, minus times minus is plus, k is 1, u prime, derivative of x plus 1 square is 2, x plus 1. Since the derivative of u power n is n, un minus 1 times u prime. U is always here equal x plus 1 over u square x plus 1 square square power 4 is equal we can simplify by x plus 1 2 over x plus 1 to the power 3. We can use this formula to write the answer like this formula. We can write minus 1 power 3 minus 1, the order minus 1, the order here is the 3 minus 1, minus 1 power 2 is 1 times n minus 1, 3 minus 1 factorial over x plus 1 to the power 3. Derivative of order 4 of x equal derivative of 2 over x plus 1 power 3 k over u, is minus k u prime over u square, and we obtain minus 6 over x plus 1 power 4. Also, we can write the answer as the formula minus is minus 1 power the order 4 minus 1 times 4 minus 1 equals 3 factorial. 3 factorial is equal to 6, etc. The formula is true for the order 1, 2, 3, and 4. We suppose now the formula is true for the order n minus 1, and we must prove that the formula is true for the order n. Now suppose that the formula is true for the order n minus 1, and prove that the formula is true for the order n. Suppose that fn minus 1 is minus 1 power n minus 2 times n minus 2 factorial over x plus 1 n minus 1. We replace n by n minus 1. The derivative now of fn minus 1 of x is fn of x, derivative of order n. The derivative of k over u is minus k u prime over u square minus k. K is minus 1 power n minus 2 times n minus 2 factorial times u prime. U is x plus 1 power n minus 1. The derivative is n minus 1 into x plus 1 n power n minus 2. N minus 1 into x plus 1 to the power n minus 2. Finally, we can simplify the powers of x plus 1 to obtain x plus 1 to the power 2n minus n is n, minus 2 plus 2, 0. Now, minus times minus 1 power n minus 2 is minus 1 power n minus 1. Minus 1 times minus 1 power n minus 2 is minus 1 power n minus 1. Times, now n minus 2 factorial times n minus 1 is n minus 1 factorial. N minus 1 times n minus 2 factorial is n minus 1 factorial. Times one over x plus 1 to the power n. We simplify x plus 1 power n minus 2 by x plus 1 to the power 2 into n minus 1. So the derivative of order n of x is minus 1 power n minus 1 times n minus 1 factorial over x plus 1 to the power n. The nth derivative of ln x plus 1 is minus 1 power n minus 1 times n minus 1 factorial over x plus 1 to the power n.